Now our topic today is projectile, and we are going to link our previous topic to today's topic. Don't forget, in our last topic we did motion under gravity, from which we derived three major equations. These are three major equations we derived on our previous topic. So today's topic is projectile. Like I said, when we say projectile, we mean when an object is launched into the air and allowed to move under the influence of gravity alone. Now, take note of that area, under the influence of gravity alone, which means the horizontal component and horizontal components of velocity and force of a projectile will remain constant, because acceleration due to gravity has no effect on horizontal component. Now, let's assume that an object is projected and it follows this path. So with initial velocity u, then don't forget, when it gets to maximum height like this, the velocity will become 0. Now, the maximum height cover is this, while this place is called range, which is horizontal distance cover. Now, we are going to resolve this initial velocity into horizontal component and vertical component. Therefore, whenever we need velocity, we are going to make use of the components that we need. If we need horizontal component, we are going to use cos theta. If we need vertical component, we are going to use sin theta. Now, let's derive it first. So let's use this diagram to make it what? Easier. Have it like this. So where this one will serve as our initial velocity u, then this is horizontal component ux, then this is vertical component uy. Now this is angle of projection theta here. Now to get horizontal component, we are going to combine this adjacent and hypotenuse, which is cos theta. We say cos theta is equal to adjacent, that is ux over hypotenuse u. Now cross multiply, you have ux is equal to u cos theta. That is how I got this horizontal component us. Now for vertical component, we use the same thing. So in that case, I'm going to combine opposite and hypotenuse, which will give us sin theta. Now sin theta is equal to opposite, that is uy over hypotenuse u. And cross multiply, we have uy is equal to u sin theta. Now, so whenever we need horizontal component of initial velocity, we are going to use this. For vertical component, we are going to use this. And don't forget, I said we are going to link the topic together with the previous topic. I'm going to make use of these equations. Now, we are going to start from time taking to reach this maximum height. Now, to get total time taking, we are going to multiply our result by 2, because if an object use certain time to reach maximum height, it will use that same time to return back to the point of projection. So we are going to make use of this equation. We have v is equal to u, but because object is going up, it will be negative minus gt, where final velocity, like I said, is equal to 0. Then initial velocity, we need vertical component this time around because the object is moving up. So we are going to use u sin theta, that is vertical component of our initial velocity, minus gt. Then you bring this one here, we have gt is equal to u sin theta. Then make t the subject of formula. T is equal to u sin theta over g, and this is time to reach maximum height. Now, in order to get total time taken or time of flight, it will be t, that is total time taken or time of flight, is equal to 2 multiplied by time to reach maximum height, 2 small t, where our small t is equal to this. Therefore, total time taken or time of flight is equal to 2u sin theta over g. So this is formula for calculating total time taken or time of flight. Now let's go to formula for finding maximum height. For maximum height, so we are going to make use of this equation that contains h. So in that case, we have v squared is equal to u squared. Because it's also going up, it will be minus 2g8. So our aim is to make this h the subject of formula. Then we replace u, where final velocity still remain what? 0. So we are going to have 0 is equal to u. Our u for vertical component is u sine theta. U sine theta in bracket square, because of this square, minus 2g8. Let's bring this one to this side. So we are going to have 2g8 is equal to, open the bracket, u square sine square theta. Then just make this, h the subject of formula. We have h is equal to u square sine square theta over 2g. So this is formula for finding maximum height reached by a projectile. Now the next one is range, the horizontal distance cover. Horizontal distance cover. So in that case, we are going to make use of the third equation, this. Now, like I said at the initial stage, that when an object is moving along horizontal component, gravity has no effect. So g becomes 0. That's why I said the velocity and force of a projectile remain constant because gravity has no effect on them. Now we are calculating horizontal component of the distance cover now. So we are going to have x is equal to ut plus or minus r gt squared. But because we are dealing with horizontal component, acceleration due to gravity becomes 0. So the whole of this one will become 0. Then we have x, that is range, is equal to ut. Then dt is not time to reach maximum height, but total time taken. So we are going to replace this t with the time and formula we got for total time taken. Then u will be replaced with what? Horizontal component of the initial velocity, which is u cos theta. Therefore, our range is equal to u cos theta multiplied by total time taken. That is 2u sin theta over g. Therefore, range is equal to u multiplied by u, you have u squared, then times 2u, 2 sin theta cos theta, everything over g. Then, in our trick, 2 sin theta cos theta is equal to sin 2 theta. 2 sin theta cos theta is equal to sin 2 theta. So we are going to replace the whole of this by sin 2 theta. Therefore, range is equal to u squared sin 2 theta over g. This is formula for finding range. Then the last one under the same range is maximum range. So in this case, if you want to throw an object and you want that object to cover very long distance, that is maximum horizontal distance, you must throw that particular object at angle 45. Especially when we are dealing with our javelin shot put, you throw it at angle 45 to the horizontal. So in that case, our theta will become 45 degrees. So we are going to use that same formula for the range. So since ordinary range r is equal to u squared sin 2 theta over g, but in order to cover maximum range, the theta must be 45. Therefore, range for maximum is equal to u squared sin 2 open bracket 45 degree, everything over g. Therefore, maximum range is equal to u squared sin 90 over g, where sin 90 is equal to 1. Therefore, maximum range is equal to u squared over g. So this is formula for finding maximum range, while this one is formula for finding ordinary range. So that is the end of the topic for today.